Hello friends, my name is Bharat Mehta and today I am going to explain you how to solve recurrence problem using Master's theorem. For finding the time complexity of recurrence relation problems, we have the two methods. Number one is substitution method and the second one is Master's theorem. Coming to the substitution method, which is applicable for all recurrence relation problems, but it is slow and time consuming and has more typical calculations, which comes under the disadvantage of this method. So for that we have the faster method or the master method, that is master method, but it can only solve the limited number of questions for finding the time complexity. And for that the format of the question or the equation should be Tn is equal to Atn by b plus Fn, where a should be greater than or equal to 1 and b must be greater than 1. The solution for the equation is Tn is equal to n log Ba into Un. So for finding Un, we have to first find Hn because the value of Un depends on Hn, and the formula for finding Hn is equal to Fn divided by n log Ba. So after finding the value of Hn, we will be correspondingly finding the value of Un. So there is a relationship between H and Un which is given here, and there are three cases such that the value of H will determine the value of Un. So if Hn, and the first case is n raised to the power r such that r is greater than 0, then the value of Un will be big O of n raised to the power r. Second case is n raised to the power r such that r is less than 0, then the value of Un will be big O of 1. And the third case is log n raised to the power I such that I is greater than equal to 0, then the value of Un will be log base 2 n raised to the power I plus 1 divided by I plus 1. After finding the value of Un with the help of Hn, we will be putting the value of Un in the solution equation as to find the time complexity. So now let us solve recurrence relation problems using Master's theorem. So the question here is Tn is equal to 8t into n by 2 plus n square. So comparing with our initial equation, that is Tn is equal to 80 n by b plus Fn, we will be getting the values of a, b and Fn. So after substituting the value of a and b in our solution equation, we get n log base 2 8 into Un, that is n cube into Un. So for finding the value of Un, which depends on Hn, so we have to first find the value of Hn, that is Hn is equal to Fn divided by n log Ba. So putting the values of Fn and a and b in the equation, we get n square divided by n log base 2 and 8 is equal to n square divided by n cube, that is equal to 1 by n, and that is equal to n raised to power minus 1. Now we would be comparing the value of Hn with the three cases, that is the first case is n raised to power r where r should be greater than 0. No, r is less than 0. Coming to the second case, n raised to the power r such that r is less than 0. Yes, this one is the case here, that is n raised to the power minus 1. So the value of Un for this case will be big O of 1. So after putting the value of Un in the solution equation, we get the time complexity of the equation to be big O of n cube. Now let us see another question for the better clarification of the topic. So the question is Tn is equal to Tn by 2 plus c. So after comparing with the main equation, that is T is equal to Atn by b plus Fn, we get the values of a, b and Fn. Coming to the solution equation, that is Tn is equal to n to the power log Ba into Un. After substituting the values of a, b, we get n log n raised to the power log 2 1 into Un, that is equal to Un because log 1 is equal to 0. So here the value of Tn comes out to be Un. So now we have to find Un. So finding Un, again we have to find the value of Hn. So after substituting the value of Fn, a and b in the equation of Hn, we get the value to be c divided by n raised to power log 2 1. that is equal to C divided by N naught, that is C. Let us compare and check our Hn value with the three cases. Case 1 is saying n raised to the power r, but there is no power in the value of Hn that we are getting, as the value of Hn is constant. So the case 1 and case 2 are not valid here. So we have to use the third case because it is the only case that is left over here. So we will be using the third case, that is log n to the power I, that is I greater than equal to 0, and for that the corresponding un value will be log 2 n to the power I plus 1 divided by I plus 1. Using case 3, the value of Hn is equal to log base 2 n to the power 0, that is 1. Because our value of Hn came out to be C, so I have written it in the format of the equation that was given here to get the corresponding value of un. So using equation 3, the value of un comes out to be log base 2 n to the power 0 plus 1 divided by 0 plus 1, that is equal to log base 2 n into C. That comes out to be log base 2 n into C. So this is the value of un that is coming out. So when we put the value of un in the equation of Tn, that was Tn is equal to un, so the value of Tn comes out to be big O of log 2n. That's the answer.